Okay, dear students, how are you all? This is Professor Varun and welcome to this video. In this video, we are going to talk about different modes of heat transfer. And this topic, from the old syllabus point of view, it was 8.2. From new syllabus point of view, it is named as B2. Okay, so let us first understand what is heat transfer. So what is happening now? So till now we have learnt about the specific heat capacity, and the formula was Q is equal to mc delta T. Then the latent heat, which was like Q is equal to m into L. In that topic, in the topic of calorimetry, yes, the heat was transferred, ice was melting, it was becoming water, but time was not one of the criterias there. Like in the formula, there is no time there. This capital T is the absolute temperature, Q is the heat, but there was nothing about time. In this topic of heat transfer, we have time also. So we are not only concerned with how much heat is being transferred from one end to the another, but we are also concerned with respect to time, how much heat is being given, like what is the rate at which heat is flowing through the body. That is what we are going to concentrate on. Now, whatever mode of heat transfer it could be, but what are we concerned with? We are concerned with the rate of heat transfer. It is like dq by dt, or the speed at which heat is being transferred within the body from one point to another point. Now, how many types of modes of heat transfer are there? So the point number one is conduction. Point number two will be convection, which is usually taking place in liquids, and conduction usually takes place in solids. Okay, I would be elaborating one moment. And the point number three is radiation. Now, conduction is that mode of heat transfer which is popular in solids, and obviously in solids the molecules are not moving, they are not changing their position, so the position is not changed, but as they're gathering heat they keep on vibrating at the same location. They vibrate and they start pushing the another molecule which is side by side, like adjacent to it. So if one molecule starts vibrating, it starts disturbing the other molecule. So the other molecule, it also starts vibrating. Gradually, this vibration is passed on from one molecule to the another molecule to the another. And so it usually takes a lot of time. It is the slowest mode of heat transfer. And gradually the heat is transferred. And even these molecules, they start vibrating somewhat. Not very high, but a little of the vibration is taken up by these molecules, depending upon the temperature. So this end, we will say that the temperature is TH. And at this point, we will say that the temperature is TC. These two temperatures are maintained. You can't say that heat has been transferred and so this end now the temperature is reducing. We are not taking up that condition. This temperature is always TC. We will not say that the heat was given and the temperature is rising. That is not in our syllabus. So we will assume that these two temperatures are not changing ever for us. Now, coming to this convection here. So convection is more popular mode of heat transfer in liquids. So what happens is the bottom of the liquid, it starts gathering heat and the molecules start moving up and the colder molecules are going down. Okay, let me elaborate this. Okay, let's say this. So what is happening in convection is these are the molecules sitting here. So when they are heated, these molecules are they're gathering heat. Because they start gathering heat, they are heated up. As the temperature rises, the density of these molecules reduce. So they become lower in density. And the upper liquid here is higher in density. And because of that, it is heavier. The hot liquid down here, it becomes lighter. The liquid above is heavier. So definitely they are going to swap their positions. The hot liquid is going to move up and the upper liquid is going to move down. This gives rise to the convectional crunch here, like the molecules start moving like this, so the water moves like this. So there are convectional crunch. Some hot liquid is going up and the colder liquid is going down. So in this kind of mode of heat transfer, The molecules of the medium are actually changing their position from one point to another. They are actually moving, they are taking up heat and they are going to the another location and sharing their heat with other molecules at that location. This mode of heat transfer is called convection. Okay. And now radiation. There is nothing much to note in the topic of convection, so I will not make another video on convection. Okay, so I'm giving all of the information in this video itself. So this is convection. There is one method in which even conduction can take place in liquids. Now that is a very special case, so you have to understand this. Like, let us say this is the liquid here and we are not heating it from bottom, we are not heating it from bottom, but the upper plate, like this upper plate is now, let us say this is the heating plate and it is now heating. So the temperature here is maintained at TH and this temperature is TC. So now this liquid, like the upper liquid, is getting hotter. The hotter liquid is having lesser density and the lower liquid will be having more density. It will be heavier. So heavier will go down and it will remain down. And this liquid which was getting heated up, it is going to maintain its position and now the liquid is not going to create the convectional crunch. It means this is not going to change its position. So they are just going to vibrate at their own location because they can only go upper side, they can't go downwards. And so there is no space upward, so they are not going upward. And downward, heat will be transferred downwards by the method of conduction. Now, this becomes the only method of conduction in which the heat can be transferred from the upper end to the lower end in the liquids. Otherwise, liquids will always be having convection. Having said that, now we are moving towards the radiation. So, radiation is fastest mode of heat transfer, fasted mode as per as the speed is concerned, because radiation is that mode of heat transfer which is taking place without any intermediate medium. It does not need solid, it does not need any liquid or gas molecules. It can move through the space also. Why? Because it is actually held with electromagnetic radiation, that is infrared radiation. So this is the radiation which is a part of sunlight spectrum. So this radiation is coming to us straight away from the sun, and you can clearly see that between sun and earth there is only space. There is actually no medium, it's a vacuum there, so there is no medium there. So if there is no medium there, how is heat being transferred? It cannot be conduction, it cannot be convection, because both of them need medium. But in the case of radiation, no such medium is required. This electromagnetic wave was discovered in 1862 by Maxwell, and he created this theory that there is no radiation, no medium that is required for this kind of a radiation to travel. That is what is radiation. Obviously, they are traveling with the speed of light, and that is why it is known as fastest mode of heat transfer, and it does not need any medium to transfer heat. Having said that, so this was the introduction. Earlier I was believing that in this video I will start discussing conduction, but as it turns up, it has already taken up kind of 10 minutes for me, so that will be the end of this video. This is the introduction for mode of heat transfers. In the next video I would be discussing about the conduction of heat in details. Okay dear students, so all the best. Bye.